Today, we're turning our gaze to the southern celestial hemisphere, to a constellation that, for all its faintness, acts as a crucial signpost, a guide to the hidden architecture of our universe. We're going to explore the constellation Norma, the Carpenter's Square.
If you were to look up at a clear southern sky, your eye would naturally be drawn to the brilliant stars of Scorpius or Centaurus. And tucked away among these celestial giants, Norma is, well, it's remarkably unremarkable. Just a faint, modest pattern of stars.
So, this brings us to a fundamental question. Why on earth do astrophysicists consider this dim patch of sky one of the most significant regions for understanding our place in the cosmos? The answer, it turns out, isn't about what's easy to see, but about what lies deeply hidden.
To really get why Norma matters, you have to understand that it represents a fundamental shift in how we see the sky. Think about it. Ancient constellations like Orion or Leo, they embody myths and legends, but Norma belongs to a new class, one named for the tools of science and art. It's a symbol not of ancient drama, but of empirical measurement.
Okay, so in our first section, let's break down the constellation's fundamental properties, its astronomical profile, and its rather peculiar history, which includes a notable stellar paradox.
So let's get the basic numbers on the table. Norma covers just over 165 square degrees of the sky. That makes it the 74th largest constellation out of 88. And under ideal conditions, you can only see about 42 of its stars with the naked eye. Statistically speaking, it's pretty insignificant. Its visibility is also pretty limited geographically. For observers south of the 30th parallel north, it's fully visible. But between 30 and 48 degrees north, you'll only see it partially, scraping along the southern horizon. And for anyone north of 48 degrees, it doesn't rise at all. It is, without a doubt, a southern constellation.
And this is where we encounter a significant anomaly. Anyone who studies astronomy knows about the Bayer designation system, right? The brightest stars in a constellation are labeled alpha, beta, gamma, and so on. But as the slide asks, where are Norma's alpha and beta? Their absence is a real historical puzzle.
The explanation, it turns out, is not astronomical, but historical. The two brightest stars that originally belonged to Norma were reassigned during a redrawing of celestial boundaries by later astronomers. They were essentially swallowed up by their bigger, flashier neighbor, Scorpius, becoming N Scorpii and H Scorpii.
This story of shifting boundaries, though, really pales in comparison to the constellation's true significance. We're now shifting our focus from the visible stars to the vast, invisible structure that's defining our galaxy's trajectory, the Great Attractor.
It's a fundamental principle of cosmology that nothing is static. Our own Milky Way galaxy is hurtling through the intergalactic medium at a colossal speed.
And that speed is approximately 600 kilometers per second. To put that in perspective, that's over 2 million kilometers an hour. It's just a mind-boggling velocity on a galactic scale.
This, of course, leads to the obvious question: what's the destination? What gravitational influence could possibly be powerful enough to pull not just our galaxy, but our entire local group of galaxies in one particular direction?
The answer is the Great Attractor. It's not an object really, but a region, a massive concentration of mass, and a gravitational focal point at the heart of the Laniakea supercluster. This is a gigantic cosmic structure that our own galaxy belongs to, and we're just a tiny member on its outskirts. Its effective mass is on the order of tens of thousands of galaxies like our own. The gravitational bullseye of this anomaly is a massive cluster of galaxies known as the Norma cluster, located directly in the direction of the constellation. But here's the catch: our view is blocked by the thick gas and dust in the plane of our own galaxy, an area astronomers call the zone of avoidance. So, from the unimaginably large and invisible, we now zoom into a specific, observable, and extremely violent system within Norma's borders, a system known as APEP, which is a potential cosmic catastrophe in the making. So what you have in the APEP system is a binary pair of incredibly rare and massive Wolf-Rayet stars. These stars are very late in their evolution, they're burning helium in their cores, and they're shedding enormous amounts of mass through powerful stellar winds. As these two stars orbit each other, their winds collide, and the rapid rotation of the system shapes all that resulting gas and dust into a magnificent pinwheel spiral.
Now, the crucial point here is that this system is considered the closest known progenitor of a long-duration gamma-ray burst. When one of these stars finally collapses, it's expected to produce an exceptionally powerful supernova, potentially beaming high-energy radiation across the galaxy. It is, for all intents and purposes, a cosmic ticking time bomb.
Beyond these two major phenomena, Norma's location along the plane of the Milky Way makes it a really rich field for observing other deep sky objects.
For instance, you've got NGC 6067, a brilliant open cluster containing hundreds of young, hot blue stars. We also find the Ant Nebula. Its intricate lobes tell a story of a complex and violent ejection process from its dying central star. And then, in striking contrast, there's the Fine Ring Nebula, a planetary nebula that appears as an almost perfect, ghostly circle. Its true shape is still a subject of scientific debate.
And this brings us to our final section, where we look at the historical and intellectual context of Norma's creation. Because to understand this constellation is to understand the spirit of the age in which it was conceived.
The constellation was charted by the French astronomer Nicolas-Louis de Lacaille during his scientific expedition to the Cape of Good Hope. He originally named it Le Quart et la Règle, French for the square and ruler, before the name was simplified and Latinized to Norma.
Lacaille's whole project was driven by a philosophy born of the Enlightenment. He believed that the newly mapped southern skies shouldn't be populated with more myths, but should instead celebrate the tools of human ingenuity, the instruments of architects, artists, and scientists.
So the constellation represents not a drama of the gods, but a drama of reason. It's a monument to the human drive to order, measure, and comprehend the cosmos through the application of logic and mathematics.
And so we come full circle. This faint pattern of stars, conceived as a tool of measurement, coincidentally points directly towards the greatest gravitational measurement challenge in our cosmic neighborhood. When you look at Norma, you're looking past the stars, through the dust, and toward our collective galactic destiny, pulled along by the vast unseen mass of the Great Attractor.